11.6 notes for geometry. A sector of a circle is a region bounded by two radii and an arc. All right, so it's just like a piece of a pie. You have your two radii and your arc. A segment of a circle is a region bounded by a chord of the circle and its corresponding arc. So here's your chord, and then the corresponding arc would be here, so this would be the sector of the circle. Theorems and postulates. So the first one says the area of a circle is equal to the product of pi and the square of the radius. And you already know this formula. So area of a circle is equal to pi r squared, where r is the radius. The area of a sector of a circle is equal to the area of a circle times the fractional part of the circle determined by the sector's arc. So, area of a sector. So if we have a circle and we have two radii bounded by the arc, we're going to label it HOP. So the area of sector HOP is equal to the measurement of HP, the arc, divided by 360 times the area of the circle, which is pi r squared. And r is going to be representative of the radius. arc HP is the measure in degrees. Okay, so let's do some examples. Example 1 says find the area of a circle whose diameter is 10. So if the diameter is 10, you know that your radius is equal to half of that, which is 5. So the formula for a circle is just equal to pi times your radius squared. So the exact answer would be left in pi, 25 pi. Your area is 25 pi units squared. You guys know how to do this. Find the circumference of a circle whose area is 49, this should say pi. All right, 49 pi square units. So area is pi r squared. If we know that the area is 49 pi, then we can solve and get the radius. So if we divide both sides by pi, those cancel, and we get 49 is equal to r squared. When you take the square root of both sides, r is equal to plus or minus 7, but you cannot have negative 7 in a circle, so the radius is 7 units. Now to find the circumference, circumference is 2 pi r, or pi times diameter, which is 2 times pi times 7, so your circumference is 14 pi. And that would be just units, not units squared. Example 3 says, find the area of a sector with a radius of 12 and an arc of 45. So if we were to draw this circle, we have a radius of 12 and an arc of 45 degrees. So we're going to use that information and plug it into the formula. Area equals 45 over 360, because that'll be the fractional part of the circumference, but then we need to multiply by the area of the circle, which is pi r squared. So pi times your radius squared. 45 over 360 simplifies to 1/8. 12 squared is 144, and we're going to multiply that by pi. So you end up with 144 pi over 8. 144 divided by 8 actually gives you 18. Then you have 18 pi, and we're finding the area, so it's units squared. Example 4, the measure of an arc of a segment AB is 90. The radius of the circle is 10. Find the area of the segment. So we're going to draw a circle. and we have a radius of 10 and another radius of 10, and they say that the measure of an arc of a segment is 90. So we need to realize that a segment is this piece, A to B, and from here to here it's 90 degrees, which also means this is 90 in here because this is a central angle. All right, so I've not given you a formula to figure out how to figure the area of this piece. However, you do have a formula that will figure out the area of your sector, and you also have a formula to figure out the area of a triangle. So what you're going to do with these problems is the following. Okay, so essentially what you're doing is the following. You're finding the area of your sector, then you're going to subtract the area of the triangle, and that will give you the area of your segment. So let's figure this out. The area of a sector, the equation is the measurement of your arc over 360 multiplied by the area of the circle, which would be pi r squared, which is 10 squared. So we have 90 over 360 can simplify to 1/4 times 100 pi. And then these can simplify to 25 pi. The area of the triangle would be 1/2 your base, which is 10, times your height of 10. So we have 1/2 of 100, which would be 50. When we subtract these, you get your area, units squared.